So I want to talk to you about geological net zero, which people ask me sort of, do we need another new phrase here? And I'd like to start off by saying, actually, it's what we meant by net zero at the beginning. But net zero has come to mean many things to many people, to the point that some people are even asking whether it's a useful phrase at all. So one way to become a world leader in something is to come up with a new phrase. So I can say, I'm a world leader in geological net zero because nobody else is talking about it yet. Okay, let's see how that goes. But the real thing I want to talk about, as Stefan helpfully sort of introduced this, is rethinking the war on fossil fuels. And rethinking it, not giving up, but rethinking our strategy in the war. Because let's think about some sort of other analogous conflicts or wars that we've been dealing with recently. The war on drugs, which was kicked off by Richard Nixon a long time ago, I think you can't really learn very much from that. But apart from two lessons, I think, from the war on drugs, which are illustrated by global fossil fuel emissions up in this top left corner. First of all, it's not going very well, and nobody likes to admit it. And that is, it's very clear from the graph in the top left. I mean, carbon dioxide emissions continue to rise. Even in places like Europe, where they're meant to be falling, and we keep saying how well we're doing in Europe. If you look at the blue line there, yeah, European emissions have gone down a bit. We've outsourced a lot of manufacturing to other parts of the world. It's not so clear what consumption-related European emissions have actually done. And recently, they've been going back up again. So we can see why the spike in gas prices, triggered by the Russian invasion of Ukraine, has driven people back to coal. So you can see coal consumption is at an all-time high, which I gather is very good for Australia, but there we are. There's always a winner in these things. But so we can't learn very much from the war on drugs. The war on COVID-19, I think, again, some of the lessons drawn from it in the early days of COVID-19, we had people saying, I don't you remember the memes going around, we are the virus, and that COVID-19 was proving what we needed to do to solve climate change was just lots more effort to keep people in their houses and do as little as possible as they were doing in COVID-19. And I think that meme rather died out as people realized that lockdowns sucked. But I mean, it does bring into perspective what the net zero challenge is. This graph, by the way, is from, and it's been slightly cut off. So if I go back to the original total fossil fuel emissions graph, my grumble about this graph from the Global Carbon Project, it doesn't show where zero is. If you want to know, it's there, and that's what it would take to limit warming to 1.5 degrees. So if you want to limit warming to 1.5 degrees, we've got to reduce emissions to zero, the emissions to the atmosphere, net emissions to the atmosphere to zero in about 20 years. That's what it would look like. And so that's the COVID contraction repeated year on year on year for 20 years. Okay? So if you think COVID shows us the way to deal with climate change, the answer is it didn't. It did teach us some lessons about the importance of using evidence and perhaps listening to results from experts and not just shouting at them all the time, and maybe we've learned something from that. But the war in Ukraine, of course, has taught us a couple of things. First of all, how completely dependent we are on fossil fuels in terms of even a relatively, in global terms, a relatively small shock to fossil fuel supplies in one part of the world has had massive ramifications over the whole world and is affecting, I gather, your gas prices here in Sydney, and people have lots to say about that. So one thing is the level of dependence that's still there. The other thing which people talk about less is the extraordinary resilience of the fossil fuel industry. They've built an LNG import industry in Europe in about 6 months. 3 terminals from nothing. And European gas stocks are at an all-time high. if it wasn't for the fact we're busy hating them for causing global warming, we'd be doffing our caps to this industry for doing that. And of course they did that not out of the goodness of their hearts, they did it because gas prices were ridiculously high and they're making a ridiculous amount of money. So I think we need to remember that lesson as well. Because, you know, it helps when you talk about fossil fuels to bring some with you. I wanted to sort of use these to illustrate the scale of the problem we face. So each of these little lumps of coal represents 500 billion tons of fossil carbon. So enough that if you burnt it, it would generate 2 trillion tons of CO2, which, if released to the atmosphere, would cause about 1 degree of global warming. So back in the sort of 2005 time, when we first realized this cumulative impact of CO2 emissions on global temperatures, we just finished, humanity, had just finished burning the first 500 billion tons. So that took us 250 years. 15 years on, we are already 1/3 of the way through the second 500 billion. And if we burn it all and release it all to the atmosphere, that'll take us to 2 degrees. And 3 degrees, 4 degrees, 5 degrees. There's plenty of fossil carbon down there. We are not short of energy. It's just got a problem. So I think it's worth really sort of dwelling on this, because at the same time that we decided, at the same time that we sort of burnt through merrily that 1/3 of our remaining carbon stock for 2 degrees, we had the Paris Agreement in 2015, at which the world's governments decided that they weren't happy with temperatures going to 2 degrees, and that was a very sensible decision given the impacts we're already seeing at 1 degree of warming, which is where we're at, going all the way to 2 degrees, and the impacts increase with increasing, the speed at which impacts accumulate increases with rising temperature, so the next degree will be considerably worse than the last one. And I think it's entirely sensible that governments have decided they want to hold the temperature increase to 1.5 degrees, but of course what that means is, at the same time that we've chewed up 1/3 of this lump from one side, we've lost half of it from the other, because we've moved the goalposts forward and decided we want to stop at 1.5 degrees rather than 2. So if you remember nothing else from this talk, remember this: we will generate more carbon dioxide from burning fossil fuels than we can afford to dump in the atmosphere and meet our climate goals. I'm more certain of this than just about anything else you can be certain of in the climate space. Of course, it's not mathematically certain, but that's the path we're on. We're going to run out of the 1.5 degree carbon budget, as it's called, within a decade or so. After that, any carbon dioxide that we still generate from burning fossil fuels is going to have to be got rid of permanently and not left in the atmosphere if we're even to get back to 1.5 degrees. Never mind limit the warming to that. So that's where we're at. That's the challenge. And one of the decisions made in the Paris Agreement, because governments were actually not even at all sure they could manage to limit warming to 1.5 degrees, was to commission this special report on 1.5 degrees, which I was heavily involved in. And this is one of the headline statements in that report, which I think introduced the net zero, the phrase net zero, really to the wider world. And it's one of these convoluted sentences where you know that it's the product of lengthy negotiations in the middle of the night in one of these, the Intergovernmental Panel on Climate Change. The governments sort of negotiate the language of the summary in a now fairly familiar way. So here we are. So it's reaching and sustaining net zero global anthropogenic, just means human-induced carbon dioxide emissions, and declining net non-CO2 radiative forcing would halt, I think we started with stop, but that was considered too much for some governments, would halt human-induced global warming on multi-decadal timescales. By the way, that net non-CO2 radiative forcing phrase basically means other emissions, mostly methane. But we're going to focus on CO2 in this talk. So here's what it means. if you want to stop the warming, you need to get CO2 emissions to net zero, and you need methane emissions to go down if you want to limit warming to well below 2 degrees or as close as possible to 1.5 degrees. So by what I'm showing you in this top panel here, and this is really important, this is carbon dioxide emissions minus removals of carbon dioxide from the atmosphere that occur directly as a result of ongoing human activities. And these go down to net zero before the end of the century in the case of 2 degrees, and around the middle of the century in the case of scenarios that limit warming to 1.5 degrees. We also see a reduction in methane emissions, and there's a lot of focus on, a lot of people want to talk about methane at the moment, mostly because they don't want to talk about CO2. It's a good displacement activity. And it's true that methane is a powerful greenhouse gas, and reducing methane emissions is useful. But when I see statements like on the Global Methane Pledge that it's the single most important strategy for solving climate change, no, there's something else you need to do as well. Those methane reductions would reduce global temperatures in the second half of this century, and these are the sort of maximum methane reductions that are believed to be possible, by 0.2 to 0.3, 2 to 3 tenths of a degree. Okay? These carbon dioxide reductions, which are what we achieve in these scenarios to limit warming to 1.5 degrees, would reduce the rate of global temperature increase by 0.2 degrees per decade. So everything we can do with methane is worth about a decade of CO2-induced warming. So when you hear, as you may well hear, triumphant progress on methane as the main headline result in the COP28 climate conference coming up in Dubai, being championed by our politicians as well, at least we've sorted methane. Remember this, okay? We need to do more. Okay, so but I'm going to focus now on CO2 for the rest of this talk. I'm not saying methane's not important, but you need to keep methane in context. So the question is have we all agreed what we're going to do and got it all sorted out? Well, in Article 4 of the Paris Agreement, parties agreed to achieve a balance between anthropogenic emissions by sources and removals by sinks in the second half of this century. And this was the language of net zero that they put into the Paris Agreement. And you know, it looks pretty clear. It does contain, however, an important ambiguity. You'll notice that it's anthropogenic emissions by sources and removals by sinks, but it's not entirely clear what sinks are included in that removals by sinks. And that turns out to be horribly important. Certainly triggered by this, and following the 1.5 degrees report, we had lots of, after the Paris Agreement, lots of countries have stepped forward and made net zero commitments. And Theresa May, when she was announcing Britain's net zero commitment, we were the first country to put a net zero commitment into law. We beat the French by 4 days. And the way Theresa May saw the point of our net zero commitment was ending our contribution to global warming by 2050. And that's what I think most people think net zero means. That's the point. And I'm very worried that Theresa May would be disappointed if it turns out that it won't end our contribution to global warming. And that's what I'm sort of why I'm preoccupied with geological net zero right now, because net zero has come to mean such a fluid idea that it might not actually deliver what Theresa May thought it was going to deliver at all. I'll explain why. Since that commitment from Britain, much of the world economy is now covered by a net zero goal of some form. If you want to find out, you can go to the zerotracker.net website that we maintain in Oxford. Alice is one of the ones who actually, I think, has helped contribute to this. And it gives you maps of the world which show you where, what policies different countries have adopted, and whether they're in law or just in a policy document and so on. And if you click on a country, you can see, like for the UK, for example, you get a little sort of traffic light system which tells you about whether they've got a detailed plan, reporting mechanism, and so on. whether they crucially rely on international offset credits for their net zero plans. You'll notice if you look at the map in detail, there are some countries that are blue, like Gabon. Gabon has achieved net zero, although rather stingily they say self-declared. Gabon it's a very heavily forested country. It's also one of Africa's leading producers of oil and gas. And Gabon claims, defensibly, I know some of the scientists who are advising the Gabon government, and I think it is defensible, to have achieved net zero already. So what's going on? And why does it matter? Well, understanding why it matters, we've got to think about climate policy before net zero and what's going on in greenhouse gas accounting at the moment, in carbon accounting at the moment, is so potentially problematic. So before we discovered the need for net zero, the point of climate policy was in this Article 2 of the Rio Convention summed up as stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference in the climate system. So that immediately triggered, that was what was agreed in 1992, that triggered a 25-year quest from the scientific community to say what that level was. And that quest got precisely nowhere. It was very difficult to say what was a safe concentration of greenhouse gases in the atmosphere. And that was really what drove us to adopt net zero instead as the climate goal, because it was just impossible to pin down. Should it be 450 parts per million? Should it be 350? Should it be 550? That conversation was just not converging. And the reason it didn't converge, so what changed in 2009 was these papers which were published saying actually it was, the warming you got to was determined by the total amount of carbon you dump in the atmosphere, not the concentration you were at any particular year. And therefore, to stop global warming, you had to reduce emissions to net zero. And the sort of science behind that is illustrated by these simple little diagrams. So this diagram here shows you, sort of using a stylized model, but you could use a complicated model as well, it'll give you much the same answer, of what happens if you switch on carbon dioxide, a constant emission of carbon dioxide at the beginning of, in year zero, and just pump it into the atmosphere. You drive up the energy imbalance because you're accumulating CO2 in the atmosphere, you create this energy imbalance between incoming energy from the sun, outgoing energy to space, and that energy imbalance goes up steadily, slightly curved. You can see the green line is slightly concave, and rises continuously as long as the emissions continue. If you switch the emissions off, that's the red line there, the energy imbalance immediately starts to decline as carbon dioxide is redistributed out of the atmosphere into the biosphere and the oceans. So that's one sort of little experiment to hold in your head. Here's another one. Oops, here's another one. This is the warming you get from just cranking up concentrations of CO2 in the atmosphere exponentially, which gives you a straight line increase in this energy imbalance. And you can see now we've got a green line which is slightly convex. So you see it's curving upwards slightly. And now when we stop the increase in CO2 concentrations, the red line continues to rise. So when we stop CO2 concentrations from rising, the warming continues. So if I combine these two experiments and ask, okay, so what happens to temperatures in panel B if I do the emissions in panel A, that's constant emissions, and then switch them off? Ta-da, drum roll, here we are. The sort of curvature of the green lines cancels nicely, and you end up with a straight line, largely by coincidence. And the downward slope of the first red line and the upward slope of the second red line cancel out, and you get something which is reasonably flat. And the light blue lines show if you sort of vary things which you're not sure about in the system, they're all reasonably flat. Meaning, after the point at which we set emissions to zero, we get no further warming or cooling of the climate system. But the crucial thing is, we get that result because of two big things cancelling out. this reduction in the energy imbalance that follows a net zero emissions and this increase in temperature that results from no further change in concentration, those two big processes happen to cancel out and you end up with a flat line. But it doesn't mean that nothing's happening. And this is really important. For the enthusiasts among you, I can give you an equation. I like equations. It's actually a very simple equation. It shows you, and it's a very important one because it tells you basically what causes global warming, or at least what causes human-induced global warming. That's the temperature change over a sort of multi-decade period. That's the length of the time period. And that's proportional to two things. Firstly, we've got this term here, which is all the emissions from carbon dioxide, from geological sources, and land use change. That's direct consequence of land use change activities, burning forests and so on. All of those emissions added up, multiplied by a constant, multiplied by the length of the time interval, because that gives you the total cumulative emissions over that period, and that gives you one contribution to the warming over that period. So just add up the CO2, and you get the warming. Now, there's another term in here, which is normally left out, but I'm showing it to you because, and the reason it's normally left out is because these two constants here, they're both rates, and they're both roughly 0.3% per year. So plus 0.3% per year minus 0.3% per year gives 0, so we forget about it. So nobody talks about this. But the point is, they're two quite big things. This term is that ongoing warming you would get if you stabilize CO2 concentrations. And if we stabilize concentrations at, say, 1.5 to 2 degrees, this ongoing warming would be 0.5 degree per century. So if all we did was, if net zero meant stabilizing concentrations, we wouldn't stop the warming, and Theresa May would be very disappointed. She looks like the kind of person I'd hate to disappoint. So that's one important term. The other important term is this removal of carbon dioxide. I call it passive removal because it doesn't involve any active intervention from human activity by the biosphere and the oceans, mopping up carbon dioxide that we've put into the atmosphere. And that's about 10 billion tons, 1/4 of current emissions per year if we stabilize temperatures at 1.5 to 2 degrees. So we tend to sort of think of it, oh yeah, climate change is caused by just dumping CO2 in the atmosphere. If we stop dumping CO2 in the atmosphere, climate change will stop. All very simple. But lots is going to be still going on after that, and we have to make sure that it does still go on. And that's why these terms, which we tend to forget about when we're talking about net zero, because they cancel and they add up to 0, they're individually very important. And if, for example, we were to take all of the emissions in this term and call them negative emissions and discover, because if we do that, we can sell them on the offset markets and make a lot of money, and put them into this term, then suddenly net zero no longer stops global warming and everybody's very disappointed. So it's a problem. We can see this happening already. Our biosphere is already responding to past emissions. These are photographs of a patch of African savanna, and Midgley and Bond had studied this very carefully, modeled it carefully, and established that much of this increase of carbon content of the biosphere there is resulting from just more carbon dioxide in the atmosphere, causing plants to grow faster. It's not always a good thing, by the way, for these African ecosystems, that these plants, it's actually, we called it natural carbon absorption because it's not entirely natural, and it is actually having quite a severe impact on ecosystems in many parts of the world. And of course, this may be happening naturally without any human intervention, but it's still happening on somebody's land, and the size of this absorption is quite significant. Just as well, I mean, we're relying on it. So Canada, for example, Canada's forests, despite the forest fires, which of course act in the opposite direction to re-release this carbon back to the atmosphere, despite the forest fires, Canada's forests were absorbing almost 1 billion tons of carbon dioxide per year over the past 20 years. Canada's emissions were about 750 million tons of carbon dioxide. And under the UN's accounting rules, if all of Canada was declared managed land, they'd be able to say they'd achieved net zero already. Now, Canada's, they're too nice to do that, so they wouldn't. But it's that's the size of the loophole that we've left in the definition of net zero. So the mistake we made, and sorry if this is a bit of a sort of mea culpa talk, but I didn't see this coming. Back in 2009, we counted this passive carbon uptake that requires no further human intervention as just natural. We just included it in the equations as something that would happen, and we didn't count it as a negative emission. However, the UNFCCC accounting rules, which actually predate those 2009 papers, but we were a bunch of physicists, we weren't interested in accounting rules, so we didn't go and check, allow countries to count carbon uptake as a negative emission if it takes place on managed lands. And then, that's the jargon, and then you can sell it on. And now that carbon has a value, and the offset markets are blossoming all over the world, lots of land is managed. And we're seeing offers like this one. I should stress, other large fossil fuel companies are available, as the BBC says, but here's just one example of a fossil fuel company offering to allow you to drive carbon neutral by protecting and replanting forests. So that's what's happening, and of course that's happening on land. It's only a matter of time before people start talking about managed oceans, and there are plenty of countries in the vicinity of Australia who have vast amounts of oceans around them compared to their actual emissions. And if they start taking credit for that and selling it on the offset markets, then of course you siphon all the carbon that would have been balancing the other term that added up to zero in that equation. You siphon all that, put it in your negative emissions term, and net zero no longer means stopping global warming at all. So here's the numbers. That's where we are. The red is fossil fuel CO2 going into the atmosphere. The green and blue is this passive uptake by the biosphere and oceans, and the hatching indicates the component that is a response to historical cumulative emissions that would continue even if we were to stop emissions immediately. If you sort of maxed out on offsetting, so to speak, and reduced your fossil fuel emissions by around a factor of 2, then, if you did that instantaneously, just to sort of imagine doing this, it wouldn't be possible, but imagine you were to do this, then these bars all add up. They add up to 0, okay, so there's no further, the pale blue bar, which is increase in CO2 in the atmosphere, that's gone to 0. And under current accounting rules, you'd be able to declare victory immediately. That, of course, wouldn't last very long, because as soon as you stop emitting, the uptake by the oceans and biospheres slows down. But within a decade or two, you'd get to this sort of situation. Fossil fuel emissions around a quarter of what they are now, balanced by uptake, by this passive uptake by the oceans and biosphere, and no further accumulation of carbon dioxide in the atmosphere. But that's not enough to stop the warming. If we actually want to stop the warming, you'd also have to deal with Earth system feedbacks as the Earth was warmer, releasing methane and carbon into the atmosphere due to the warming itself. But that's that ongoing passive uptake by the biosphere and oceans due to past cumulative emissions that would be going on, which you could, in principle, use to balance your ongoing fossil fuel emissions under the current accounting rules for carbon that we use. To actually stop the warming, we need what we've called durable net zero, where you're balancing everything. You're balancing fossil fuel emissions, in particular any remaining generation of CO2 by burning fossil fuels, with engineered removal of CO2 from the atmosphere and permanent geological disposal. This situation here means that you're allowing the green and blue below the line bars to suck carbon dioxide back out of the atmosphere. That gives you a net decline of 0.3% per year, which is what you need to stop 0.3% per year of cumulative emissions to date, which is what you need to stop the warming. Without that, the warming won't stop. And the problem is, with a clever enough accountant, all three of those on the left could be count as net zero. And I know that Macquarie University trains lots of clever accountants, and this is why I'm urging Stefan to get stuck into this problem, because I'm sure we're training people who will be able to game this, so we need to also train them in what the consequences will be of maximally gaming our current carbon accounting rules. I hope you're all familiar with the Hitchhiker's Guide to the Galaxy, and there's a scene in that where the scientists have been getting the computer to calculate the answer to life, the universe, and everything. So these days, it's not 42, really, it's net zero. Everybody agrees net zero is the answer. But like the scientists in the Hitchhiker's Guide, we suddenly realized we forgot to say exactly what the question was. And this is worrying me. So part of the answer, it's only part of the answer, but it's a part of the answer of any scenario that actually stops global warming, is this geological net zero, this balance between any remaining production of CO2 in red from burning fossil fuels with active removal and return of CO2 to the geosphere. And this is the requirement that I keep coming back to, that it's a necessary component of any durable net zero regime. If we look at the scenarios that meet the goals of the Paris Climate Agreement, that allow all technologies to be deployed within these integrated assessment models they use to assess the most cost-effective way of achieving Paris Agreement goals, we see two things. First of all, very importantly, we do see that we reduce the amount of fossil fuels we burn. So we produce less CO2 from burning fossil fuels, and by, of course, replacing them with solar and wind and using them more efficiently and all the rest of it. So that's 2/3 to 3/4 of the solution. But it's not all of it. We don't get fossil fuel use to zero at any point in this century. The heavy lifting is done by storing the remainder back into the Earth's crust. And in these models, most of that's done with so-called carbon capture and storage, either from point sources or from bioenergy with carbon capture and storage, where you're burning biomass in a power station, capturing the CO2 and re-injecting it into the Earth's crust, which allows you to net, if you do it right and your biomass source is sustainable, and lots of ifs, which generally are not met, then you have in principle a net negative energy source, which actually takes CO2 out of the atmosphere. So you'll see here there is also a contribution from reducing deforestation and from implementation of nature-based solutions to draw down CO2. And I know there's, I was reading in the press just last week how there's a lot of interest in this and the use of land for the net zero in Australia. Globally, it makes a contribution, but you can see the green line's quite close to the black zero line. It's helping, but it's not the main story. And worse, it's confused by this natural, or sort of not quite natural, uptake of CO2 due to past emissions, which is the dotted line here. So even if you're succeeding in getting your solid green line down to zero and then below zero, meaning you're succeeded in going from where we are now, taking carbon out of our biosphere, to putting it back, you wouldn't necessarily know that you'd succeeded, because you're sort of having to monitor that in the context of large carbon fluxes that are happening for other reasons as well. So it can help, but the main story is getting to this geological balance between any remaining CO2 that's still produced by burning fossil fuels and CO2 being restored to the geosphere, put back underground. In a sense, solving climate change is extremely simple. we currently restore to the geosphere 0.1% of the carbon dioxide we generate by burning fossil fuels. 1,000th. To stop climate change, we need to increase that factor by a factor of 1,000, and we're done. So what do we have to do it? So first of all, where to do this and how? I mean, where to stash your carbon, so to speak. Barrow Island is a popular suggestion in Australia. This is one of the world's largest CO2 injection facilities, where Shell are injecting CO2 underneath Barrow Island because of the CO2 that's associated with the natural gas deposit there. It's a project that has many critics, but one thing I'd like to stress about that project is the technology is working. We can talk about the wider context of the project and what isn't working, but the tech works. You can stick CO2 back into the ground and it stays there. We know that. There are other ideas. Olivine, you can react CO2 with olivine, a rock which is widely available in New Zealand. I gather there's some in New South Wales as well. And that turns CO2 in effect back into rock, and so that gets rid of it permanently as well. You can buy carbon credits, but as is hinted by this picture, that's not such a safe place to put your CO2. And the riskiest place to put your CO2, of course, of all, is into the atmosphere. The problem is the actual risk to you, if you're a CEO of a company making a decision about what to do with your CO2, is exactly the opposite. This would be the lowest risk place to put it, because you dump your CO2 in the atmosphere, it's everybody's problem, it's not your problem. Buy some carbon credits, you've sort of ticked the box for your ESG requirements, otherwise you're out of the, you've got nothing to worry about. These two permanent storage mechanisms would be quite risky for a company to actually embark on doing them. So by the way, full credit to Chevron for actually doing this. It's a big, it's a big effort. But anyway, we can come back to that. I'm sure we may well come back to that. I'm sure when we get to questions. As Stefan put it in the introduction, we need to stop fossil fuels from causing global warming. That's a sort of obvious thing to say. But what people don't seem to realize or haven't yet accepted is we need to stop fossil fuels from causing global warming. We almost certainly need to stop fossil fuels from causing global warming before the world stops using fossil fuels. Remember this lump of coal. We're a third of the way through it already. We're burning it faster than ever, and we've decided we want to stop halfway. We will generate more carbon dioxide from burning fossil fuels than we can afford to dump in the atmosphere. If we look at these scenarios, these are sort of 4 generic scenarios from the IPCC's 1.5 degrees report, which all meet the goals of the Paris Climate Agreement. They do it in 4 sort of different pathways, 4 different ways, but the 2 that involve elimination of fossil fuels, they're number 1 and number 4. You'll see that the dark green fossil wedge is sort of phased out entirely in those 2 scenarios. One of them involves an immediate, this decade, 30% reduction in global primary energy demand. And the other one, P4, involves massive amounts of bioenergy production in the second half of this century. Neither of which look, well, the immediate reduction in energy demand isn't happening, and nobody seems to be particularly interested in making it happen. And that level of bioenergy would almost certainly mean there wouldn't be any land left for food production. So there are some companies out there who are thinking about how to stop the products they sell from causing global warming. One of these 4 actually has a plan to stop the products they sell from causing global warming by 2050. Does anybody know which one? You can probably guess. Yes, it's Vicky Hollop of Occidental. Go figure. There is a catch with Vicky Hollop's plan, which is it's only working because Uncle Sam will pay Vicky Hollop, or pay Occidental, to get rid of CO2, thanks to the Inflation Reduction Act, which was introduced last year. So Uncle Sam will basically pay companies to bury CO2, essentially what it takes to do so. I worry about how sustainable that is, and also in other countries, without the sort of owning the world's reserve currency, whether it would be possible for other countries to actually sort of print money to pay to dispose of CO2 in the way that America seems to be planning to do at the moment. I think time will tell whether it's even possible in America. I just wanted to, if you could bear with sort of a couple more minutes just to explain how we solve the problem. Yeah, it's an important problem. We've been pushing in Oxford a way of approaching this problem without relying on the government paying for it. And by the way, whenever I start talking about carbon capture, everybody gets pretty prickly, because for everybody it means an excuse for massive corporate subsidies to not particularly pleasant companies. And that's why I fully understand why it's such an unpopular technology in Australia, because it's been sort of used as an excuse to sort of milk money out of the government without actually doing very much for decades. So we need a different way of restoring that balance between CO2 generation from burning fossil fuels and CO2 being put back into the Earth's crust. And this is a suggestion for how we could do it. So this is how to stop fossil fuels from causing global warming without relying on Uncle Sam. Okay, so this is the target. We don't want the government to have to pay for it. So this is our current situation. We have an extractor importer of fossil fuels, the blue arrows are sort of embedded CO2, and they sell the fossil fuels to an industrial refiner who sells it on as products to consumers, and it all ends up in the atmosphere. Okay, so we have the industrial point source is grumpy because they're having to pay into an emission trading system or something, and they're the only one that's really being affected by climate policy at the moment. Consumers are confused. The atmosphere is sweating. Over here we have a geological storage operator who's set up a business to store CO2 back into the Earth's crust, but they're sad and lonely because there's no reason for anybody to buy their service, because, you know, why would you? There's no incentive to store CO2 back into the Earth's crust. The government's fast asleep, and the extractor importer is laughing all the way to the bank, and they really are laughing right now. So we introduced something we call a carbon take-back obligation. This is a requirement on the extractor importer to produce some evidence that some carbon dioxide has actually produced a certificate that shows that a carbon dioxide has been verifiably stuck back underground. Some fraction, a small fraction to start with, of the carbon dioxide that will be generated by the fuels they sell has to be permanently disposed of. Okay, what happens? Well, first of all, where does that carbon dioxide come from? It'll come from the industrial point source. So the geological storage operator buys carbon dioxide from the refinery. And so, intriguingly, the industrial point source, who was implacably opposed to climate policy, suddenly discovers that climate policy is actually quite interesting, because they can sell their carbon dioxide instead of it being just a pain in the neck. Consumers are still confused and probably can't notice the difference, because it's still a relatively small fraction that we're requiring to do this. The atmosphere is still sweating. It hasn't made any difference to the climate so far. But the geological storage operator is now happy because they've got a business. There's a reason to buy their service, because the extractor importer needs their certificates in order to sell their products. The government has its nerd glasses on because it's learning how to do this, learning how to verify and monitor the CO2 storage, which will take decades. It's incredibly important. Building MRV systems for this service is going to be a multi-decade long process in establishing trust of everybody in this thing working. And we know this is going to be needed. Just remember those lumps of coal, and we should be working on building those MRVs, and we're not doing it right now. Of course, the extractor importer is very cross, because they've got a cost which they didn't have before, and so they're possibly making slightly less money. Anyway, we scale up the stored fraction. The industrial point source is making more money from selling CO2. The consumers are still confused. The atmosphere is feeling a bit better, because now the flow of CO2 into the atmosphere has declined a bit. We now have a new element coming into this direct air capture element, because the geological storage operator has actually run out of CO2 and is having to suck it back out of the atmosphere. That's a good situation to be in. The geological storage operator is making loads of money. The government's still working away, and the extractor importer, of course, is still cross. But, you know, we don't feel that sorry for them. Okay, we finally get to 100% net zero. The industrial point source is happy because they're selling all their CO2. They no longer have to pay into the ETS. Consumers are happy because we've stopped global warming. The atmosphere is breathing a sigh of relief. The geological storage operator is still making loads of money. The government is feeling awesome because it's stopped global warming. And the extractor importer has saved the planet. Is it really possible to do this? Well, it's definitely possible to get rid of CO2 back underground. The Norwegians have been doing it in Sleipner for decades. The middle panel is an artist's rendering, always be suspicious of artist's rendering, of a 500,000 ton per year CO2 air capture and storage facility. But the bottom panel is a real photo, and the middle person there is my hero, Vicky Holub, for where they're breaking ground on Oxy's, the Oxy's CO2 capture and storage plant in Texas. So it's going to be real soon, and we're going to find out if it's going to work. And it has to work. Would the cost be prohibitive? Well, this is Australian petrol prices since 2000, and that's the cost of free air capture, capturing all the CO2 generated by that petrol and putting it back underground, which would need to be phased in by 2050. So stopping petrol causing global warming would mean an increase in the cost of supplying petrol, not necessarily the selling price, it all depends what happens to taxes and profits, an increase in the cost of supplying petrol equivalent to the amount by which petrol prices have gone up since 2000, over a similar timescale. The end of the world? Probably not. If people drove slightly more efficient cars, they wouldn't even notice. Sorry, that's just a suggestion. Gas prices, it's even more striking. Here you are, domestic gas prices. Again, this is all just downloaded off the web this afternoon, so these are caution. That's what a $15 per gigajoule, which is, again, what the cost of free air capture. We know what the cost of free air capture is because they're building that plant on the back of a subsidy from the US government of roughly $250 per ton of CO2. And Oxy are not, I mean, I'm sure they're a lovely company, but they're not losing money. So we've discovered what this actually costs, and that's what it looks like compared to gas prices. Now, nobody's going to want gas prices to go up by that much, but if they went up by that much over 20 years, would it really be the end of the Australian economy? So what could possibly go wrong? Well, lots of things, of course. The sort of reactions we get to this scenario is, well, first of all, I don't trust the fossil fuel industry. I'm not asking anybody to trust the fossil fuel industry. This will only work if it's backed by absolutely rock-solid regulation. And any suggestion from the industry that they will monitor their CO2 storage themselves voluntarily should be just thrown out the door before they even start their conversation. That will definitely be the first thing they'll suggest. This allows continued fossil fuel use. Fossil fuel use is continuing, and actually requiring geological CO2 disposal would probably discourage fossil fuel use faster than any conceivable carbon price, because it means it's absolutely predictable fossil fuels are going to get more expensive. So you better start thinking about using other things instead. And then finally, there's the sort of planting trees is so much better for everybody than burying CO2, because people like trees and they don't like the idea of just sticking CO2 back into the Earth's crust. Well, this is a tricky one, because of course, we're just sort of developing this carbon offsetting industry, which is getting many of my colleagues who work in biodiversity and so on really excited about all these resources being brought into protecting forests from the carbon markets. And now they get very upset with me for saying, actually, it's not going to work. But it isn't going to work. It's certainly not to stop fossil fuels causing global warming. So only geological storage actually compensates for continued fossil fuel use. And so we are left with a challenge of who's going to pay to protect those passive carbon sinks that we need come net zero if we don't allow the offset markets to do that. I think that's an important question for us to think about. And we've got a suggestion on that, because if you just go back and think about that equation, the commitment to passive carbon uptake scales with your contribution to cumulative carbon dioxide emissions. So, for example, the UK, by 2050, even if we make our net zero goals, will have emitted 85 billion tons of carbon dioxide from fossil fuels and industry into the atmosphere over 250 years. So that's a huge amount per head of population, because we happen to start doing it about 100 years before anybody else did. And that increases that natural uptake required by 250 million tons of CO2 per year. That's two-thirds of our current, that's about three-quarters of our current emissions. So that's a huge commitment that the UK has a very clear responsibility to protect those passive sinks. So I think this is where we need to start the conversation about Everybody worries about who's going to protect the forests if you take away the carbon markets. Well, here's a suggestion as to how. Okay, implications. And I know Stefan would like me to wrap up as soon as possible. So there's these ambiguities in accounting have introduced the problem with net zero targets that actually you could balance geological sources with biological sinks and actually not stop global warming at all. If we want to stop global warming, we need geological net zero. We need any continued generation of CO2 from burning fossil fuels to be balanced by CO2 being returned to the Earth's crust. We need this to be acknowledged in national strategies and corporations, and we can, if we're worried about what's going to happen to the forests, cumulative geological emission to date actually provide a basis for allocating responsibility for that. Some people are starting to get this, and this is a quote from COP President Sultan Al Jaber, who lots of people have criticized because he's also the CEO of the Abu Dhabi National Oil Corporation, but he is saying, and this is a quote from a recent speech, we must be laser focused on phasing out fossil fuel emissions. And what depressed me is when he said that, lots of the climate establishment criticized him for saying that, rather than embracing him and saying, yes, this is what we need to do. To sum up, we need to stop fossil fuels from causing global warming before the world stops using fossil fuels. To quote an earlier quote, also from the Middle East, this one from Sheikh Yamani, the Saudi oil minister in the 70s, the Stone Age didn't end because we ran out of stones. The oil age won't end because we run out of oil. And just to bring Sheikh Yamani's quote up to date, global warming must end before we stop using fossil fuels. I'll leave you with that thought. Thank you.